filling out this blank unit circle. So if I start off with 0 degrees, and that would be 0 radians, then the ordered pair here is 1, 0, because this is a unit circle. The next angle up, the next smallest angle that I do is 30 degrees. So this must be 30 degrees. This must be 45. This is 60. And of course this one is 90. And let's just go ahead and fix our first quadrant, and then we'll talk about the other quadrants. So 30 degrees we said this is 30 degrees, and we know our numbers are 1/2 and the square root of 3 over 2. Now let's figure out which goes where. Since a 30-degree angle is going to give you a shorter vertical on your right triangle, then that's the height now of your point. That's a y value. So 1/2 is smaller than the square root of 3 over 2, so the 1/2 is the y value, and the square root of 3 over 2 the x value. Now, since we know that the same numbers are used for the 30 degree and the 60 degree, let's jump up to the 60 and see how much higher the vertical is when you drop that down to make that triangle. So you know you want the larger of the two as your y value, and square root of 3 over 2 is larger than 1/2, so we're going to put the y in as square root of 3 over 2 and the x as 1/2. If you can get that visualization, then there's much less memorization that you have to do. Now, let's go to the 45-degree angle. It was the one that has the same, because it's an isosceles triangle, the same x and y coordinates, and those were the square root of 2 over 2 and the square root of 2 over 2. So while it looks like there's a whole lot that you have to memorize for the unit circle, really there isn't. If you can get that one quadrant down, you can figure out all of the rest of it. So let's do our 90 degree. That's on the y-axis, so our x is 0 and our y is 1. And now let's go through and do our radians. 30 degrees is pi over 6 radians. And remember, if you don't know those yet, you can convert them. 30 degrees times pi over 180 degrees. Remember, we talked about the degrees will cancel. So you have 30 over 180, which is 1/6, so you have pi over 6. 45 degrees is pi over 4 radians. And 60 degrees is pi over 3 radians. 90 degrees is pi 2 radians. Now we need to fill in all of the other angles. So let's do the quadrantals. That's the way we went over them in the lecture. So we got 0, 90. If we go another 90 degrees, we'll have 180. And that is 0, pi over 2, and pi is equivalent to 180. Then if we go 90 more, we'll be at 270. And that is the same thing as 3 pi over 2. And then in the last quarter of the circle will get us around to 2 pi, a full revolution, or 360 degrees. And then our ordered pair, we already have the one for 2 pi and 0, and for 90 degrees. So at 180 degrees or pi radians, we are at -1, 0. And at 3 pi over 2, we are at 0, -1. Now the next easiest is probably to take care of our 45s. So if we have 45 degrees and we add another 45, we're at 90. And we already have that one taken care of because that's one of our quadrantal angles. Add another 45 degrees to 90 and you're at 135. And add another 45 degrees to that, you're at 180, which we already have because it's a quadrantal angle. Add 45 degrees to that and you're at 225 right here. Add 45 to that and you're at the quadrantal angle 270 degrees. Add another 45 and you are at 315. Fourth quadrant, and another 45 gets you right back up to 360. Now let's do the equivalent radians for that. I'm at pi over 4. If I add pi over 4, that's 2 pi over 4, which is pi over 2. If I add another pi over 4, then I'm at 3 pi over 4. And there's value to being able to count around your pi over 4s, or you could just convert 135 degrees to 3 pi over 4, but you need to be able to think either in radians or degrees without having to stop and convert. So 3 pi over 4, 4 pi over 4 is here at pi. Then this would be 5 pi over 4, 6 pi over 4, which is the same as 3 pi over 2 if we reduce the fraction. So then this one must be 7 pi over 4. And if I go one more, I'm at 8 pi over 4 or 2 pi. So those are all my 45-degree angles. So now I know that from the first quadrant, they have to have the ordered pair, the absolute values of those numbers are the square root of 2 over 2. So then I just put in the signs because I know in the second quadrant the x's are negative and the y's are positive. And in the third quadrant, both x and y are negative, so I'll have negative square root of 2 over 2, negative square root of 2 over 2. And in the fourth quadrant, the x is positive, y is negative. So I already knew those numbers. All I had to do was use what I know about the signs in the quadrants to fill in the correct sign. Now let's do the 60-degree angles. So we know the numbers we're dealing with are 1/2 and the square root of 3 over 2. So then if I go another 60, I'll be at 120, which will be right here. And another 60, I'll be at 180, and I've already done that one. And another 60, I'll be at 240, which must be right here. Another 60 is at 300, which must be right here. And another 60 would be at 360, and I'm back around the circle. Now let's do what we did with the radians again. I'm at pi over 3. If I go another pi over 3, I'm going to be at 2 pi over 3. Notice when I'm at 2 pi over 3, I'm just pi over 3, or a 60-degree angle from negative, going in the negative direction. So you still have a 30, 60, 90 triangle down there. And 2 pi over 3 plus another pi over 3 is 3 pi over 3, but that's at pi, and I've already done that one. Then the next, add pi over 3 to pi, and I'll be at 4 pi over 3, so that's here. And notice again that that's hanging a pi over 3 angle, or a 60-degree angle, below the negative x-axis. And add another pi over 3, that'll be 5 pi over 3. If I add one more, I'll be at 6 pi over 3, and I'm back where I started. So now I've got all my radian measures. So now let me fill in the 1/2 square root of 3 over 2. So 1/2 square root of 3 over 2, and the x's are negative in the second quadrant. Down here, 1/2 square root of 3 over 2. And this time they're both negative because I'm in the third quadrant. And 1/2 square root of 3 over 2, and this time the x is positive and the y is negative because I'm in the fourth quadrant. And I have one set of angles left to do, and those are the multiples of 30 degrees. I did the 60 degree first because as I go through with the smaller angle, I will hit the 60 degrees, the ones I've already done. So 30 degrees, and then the next one would be 60, and the next one would be 90, but I've already done those, and the next one would be 120. Well, the next one would be 150, and I don't have that one yet. And notice 150 degrees is 30 degrees from the negative x-axis. And then if I go 30 degrees beyond the negative x-axis, I'm going to be at 210. And 30 more degrees, I'll be at 240, but that is actually a pi over 3 multiple, so I've already done it. And if I go 30 more degrees, I'm at 270, which is a quadrantal angle. I've done that. Go 30 more, I'm at 300, and that's another pi over 3 multiple. And add 30 more, I'm at 330, which is just 30 degrees below where I started, the 360. And I'm done. So now let me go around with pi over 6's. So here's pi over 6. If I go pi over 6 more, then I'm going to be at 2 pi over 6, but that's here at pi over 3. Pi over 6 more is 3 pi over 6, but that's here at pi over 2. I've done that one. 4 pi over 6 is the same as pi over 2. 5 pi over 6 is right here. You can check that 5 pi over 6, if you change it to degrees, you'll get 150, or if you do 150 degrees change to radians, you'll get 5 pi over 6. 6 pi over 6 is pi. I've already done that one. 7 pi over 6 is pi over 6 below the negative pi axis, or the negative x-axis. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. And 11 pi over 6 is right here, equivalent to 330 degrees. And 12 pi over 6 gets me right back to 2 pi. And lastly, let me fill in the ordered pairs here for the pi over 6 multiples that I don't have finished. Pi over 6, 5 pi over 6, I'm going to still use the square root of 3 over 2 and 1/2, and negative x in the second quadrant. In the third quadrant, they're both negative, so negative square root of 3 over 2, negative 1/2. And in the fourth quadrant, the x is positive, square root of 3 over 2, and the y will be negative. And that's what you need to be able to do. Fill in the entire unit circle from memory, because once you've got those ordered pairs, you have all 6 trig functions, because the sine of the angle, whether it's in radians or degrees, is the y-coordinate. The cosine is the x-coordinate. The tangent, y over x. Cosecant is the reciprocal of sine, or 1 over y. Secant is the reciprocal of cosine, or 1 over x, and the cotangent is the reciprocal of tangent, or x over y. And we can further, this little positive negative up here on this particular unit circle just goes through, and you're supposed to decide which of the 6 trig functions are positive in this quadrant and which are negative, and of course they're all positive in the first quadrant. In the second quadrant, the ones that are positive will be the sine. For some reason this pen doesn't write very good at the top of the screen. I don't really know why. The sine would be positive, the cosine would be negative because x is negative. The tangent is going to be negative because it's the ratio of sine and cosine. The cosecant is going to be positive because sine is positive. And the secant is going to be negative because the cosine is negative. And the cotangent, which is the reciprocal of tangent, is also going to be negative. So you can go through the quadrants and figure out what the signs are going to be, which will sometimes help you from making a careless sign mistake. This is a neater typed version of what we just filled out.